Welcome back, ladies and gents. Mrs. Cardwell here, and today we have our new math lesson. So we're going to need a few things, few materials. You'll need your math notebook, your math floppy copy, and a pencil. Okay, so let's go ahead and we'll set aside our floppy copy for just a moment. Let's go ahead and open up to our next clean page. And as usual, we're going to go ahead and get started with our labeling of our page. Today is September 22nd, 2020. This is Unit 1, Session 2.2, and this is called Using Arrays to Represent Multiplication. All right. So yesterday, guys, we had an opportunity to work on some posters for multiplying the problem 35 times 28. And I'm going to share with you just real quickly some previous ones that I had from an older class. Different ways to break down the problem and to solve, right? So different ways of breaking down this problem so it's easier to solve. And then going back and making sure that you get all of the elements. Okay? More than one way to solve these problems. Right? We have an equivalent problem here. This person doubled the 35, then took half of the 28 to create 14. Okay? So here's some ideas. All right. But today what we're going to be using are some arrays to represent multiplication. Okay, and you might notice, ladies and gents, that with some of the methods that I just showed you, some are very different. Are there any of these representations that seem particularly clear to you, and why? Why might they be clear? And are there ways that you can use shortcuts on some of our representations? And when we talk about representations, guys, we're talking about different ways of solving. Okay? For example, instead of using 35 circles, remember our problem was 35 times 28. Instead of using 35 circles, drawing 35 circles, you can draw 4 or 5 circles using some dots or an arrow to show that you're skipping circles and draw a few more. Instead of drawing dots or objects inside the dots, you can write the numerals like we did the other day when we drew the 18 baskets and the 10 apples in each. Okay. Now I want you guys to think about how do these representations or pictures, let me show you guys another one, the one that I was talking about that we did the other day. How do some of these drawings, there we go. How do some of these drawings help us keep track of our work? All right, so thinking about where in this problem is the 18? Where is the 14? Right? And how does this representation show the product or the answers? Okay, so we're going to go ahead and we're going to take a look at two different strategies for this problem and how they can be used to create an unmarked array. Okay, so let's go ahead and we'll go back to today's page. And we're going to go ahead and get started. All right. Go ahead and move this. Makes it a little easier for us to see. There we go. Okay. So if I were to take the problem 35 times 28. Now you'll recall that this is what we did with the poster the last time, 35 times 28. So if I take this problem and decide I want to create an unmarked array, I'm going to go ahead and think about what might be my first step. My first step. I look at these numbers and I notice, oh, these are tricky ones for me to multiply mentally. These ones are tricky for me to go ahead and do. So I'm going to break them down a little bit differently. I'm going to show you guys how I'm going to do that. So 35 times 28 is tricky for me. But if I change it to 35 times 20, and that's my first step, you can see this, it's very similar, right? 35, 35. And instead of 28, I'm putting 20. So it's going to help me with my math skills a little bit, but I need to remember that there is still this 8 here. Okay? All right. So I'm going to go ahead and draw an array. Now I don't need to count across, just going to create an array. Doesn't need to be perfect, right? I just have this particular box here. Now I know that my total, I'm going to want to multiply. And I've made this a little wonky, and that's okay, because we know that 35, of course, is larger than 28. However, since it's an unmarked array, it all works out. So you guys have noticed that I put the 35 close here. And then my 28, I'm going to want to break that down a little bit into numbers that are more simple for me to multiply. So I have my 35 times 20 that I'm going to break it into. Okay, so 20 plus 8 is 28, right? So I'm not changing this number. I'm just breaking this number into two pieces. All right. I know 8 is smaller than 20, so I'm just going to go ahead and draw a line right about there. My first problem, 35 times 20. Okay, I can go ahead and think about in this way. Now, if I have 35 times 2, I know that that is 70. Okay, then I have this 0. Sometimes people just say, put the 0 over here. However, we need to recognize that this is a place value holder. And it's not just 70 plus 0, which would be 70. It is 700. Okay, so we need that place value. All right, so I have my 35 times 20, which takes care of this piece. Now, what I have left is 8. Sometimes I see students that they just go ahead and, oh, I must have to just add the 8 to it. But that's unfortunately not how it works. We still have this 35 over here. That 35 needs to be multiplied by 8. So I'm going to go ahead and 35 times 8. All right. Okay. So before I go ahead and solve our problem, go through the rest of the steps of the problem, I'm going to introduce a story context. Okay? So I want you guys to think about teams. Imagine today is field day, and all of the teams need to line up on the field to make a huge rectangle. There are 35 teams with 28 students, right? 35 teams with 28 students on them. The problem is to figure out how many students there are on all of the teams. If we start with 35 times 20, we're going to need to explain what 35 of 20 means in terms of the team. Okay, so I'm going to go ahead and just write down really quickly. I'm going to summarize that. On field day, all of the teams line up on the field in a huge rectangle. There are, I'm going to go ahead and write this in a different color, 35 teams with 28 students on each of them. Each team. Okay. How many students are there in total on the field? Okay, so that's our problem. Okay, now when we're talking about just this one piece, guys, I want you to think about for a moment this 35 out of 20. It's not the total amount of students that are out there, but the 35 teams with 20 on each. I want you guys to go ahead and think about what part of the problem, what does this mean in terms of the teams? Okay. What of the part of the problem have we solved? So this is not something to add to your, not to add to your notes, but I want you guys to think about this question. What does 35 multiplied by 20 mean if we're talking about teams? Okay, what does 35 by 20 times 20 mean if we're talking about teams? And what part of the problem have we solved? What else do we need to do? Okay, so I'm going to give you guys a moment to think about what else do we need to do or what are our next steps. You can think about it in terms of this array also. What else do we need to do to finish and to solve this problem? If you need additional time, go ahead and hit pause on your video. You can take as much time as you need. All right, let's come on back, ladies and gents. And I know that a lot of people were thinking, well, we've solved this part of our array, and now we need to go ahead and solve this piece of the array as well. Okay, so we have this 35 times 8. Now this is still a rather large number, and it might be difficult for me to multiply that one. So I'm going to break this down to even a smaller piece. Okay, so I'm looking at my 35. 35 times 8 feels like a lot for me. So what I'm thinking about doing instead of going 35 times 8, what if I were to go with 30 times 8 instead? I'm going to go ahead and break off a piece of this. I have 30 times 8. Okay, I don't go all the way down because remember, all the way down is 35. So I have this number 30 times 8. Now I can go ahead and think about 3 times 8, which is 24. And I know that I have a place value holder here. I'm not just adding a 0, it's a place value holder. So 30 times 8 is 240. Now I was able to do that part in my head. Now we have to think about, though, what is left? Remember here, I still have the 5 and I still have the 8. The 5 is in the ones column, so I can go ahead and write down 5 times 8, which equals 40. And then I have to take all 3 of my equations. I'm going to line them up very nicely and neatly. So I have 700 plus 240 plus 40. I'm going to go ahead and add those up. You'll notice how I was very careful to put all the ones in the ones column, all the tens in the tens column, and all the hundreds in the hundreds column. Keeps things nice and neat, and that's why I love this graph paper. 4 plus 4 is 8. 7 plus 2 is 9. So we get that 980 that we've been getting. Okay? Now this is one way to look at it. And you might think to yourself, oh, that totally made sense to me, right? And that's fantastic if it did. If your brain didn't quite work that way, remember we're not born, none of us are born with a math brain and none of us are born without a math brain, but maybe your brain sees things a little bit differently, and that's okay too. So there are some different ways to go ahead and go about this. All right. So we just need to make sure, especially when we're drawing these out, guys, we just need to remind ourselves, okay, this is my total problem. If I start out 35 by 20, I just need to make sure that I have the rest of that in there as well. Okay? All right. We're going to go ahead and move on down. And so a number illustration of the same way that we solved up at the top here is something that we call breaking the numbers apart. In fact, I shared that one with you guys, right? I shared this one with you. This is the breaking the numbers apart with Charles and Yumiko, right? I have my 35 times 28. 35 times 20. Remember, I still have that 8 there. I can't forget that. My 35 times 20 equals 700. Now, I can't just add this 8 in, right? I know that I still have a 35 times 8. But if I want to break down that 35 times 8 a little bit more to put in another step so that it's a more simple, straightforward math problem for me, I can go ahead and instead of writing down 35, I can write down 30, 30 times 8. But I have to remember I still have that 5, and then I still have to multiply it by the 8. Okay? 30 times 8, 240. 5 times 8 is 40, and then I come up with my answer. All right. Now remember, in all of these ones, you already know what the answer is. So in these particular pieces, these particular problems, boys and girls, the most important part is how did you arrive at that answer? Okay, more important than the answer itself. All right. So that was our breaking the numbers apart, boys and girls. Now, I wanted to share with you a few other ways that we could be looking at this. I'm just going to go ahead and put some of these examples down. Now, one of these examples might make a little more sense to you. Now, you don't have to write this down. I just want to give you guys an idea. These are all the same problem, 35 times 28. But you can see these people broke them down in different ways. So I have the 35 times 28. This person thought, you know what, 30 times 20, that's something I can do in my head. Okay, but you have to remember that we still have the 8, we still have the 5, right? So what we can do is we can break it down a little bit further. Okay, so we have our 30 times 20, and I know I still have 5 down here. I still have 8 across here, right? So I have my 30, and then I can multiply it by my 8 up here, which is 240. Then I skip down here, so we have 30 times 8 is 240, but I still have my 5 down here that is left, my 5 that's remaining. Then over here, I have my 20 because my 8 has already been taken care of. So 5 times 20 is 100. All right, so I have my 600 plus 240 plus 40 plus 100, and that's going to equal my same answer, which is 980. Okay, ladies and gents? All right, so we're going to go ahead and pause here, and I will see you in class. Have a great day, ladies and gents. Bye-bye.